So hello guys, we are going to discuss today internal rate of return. Okay, this is also called IRR. This is one of the discounted cash flows method. In discounted cash flows, last time we discussed how to calculate the net present value, and today we are going to calculate how to calculate internal rate of return. Okay, usually when we calculated last time net present value, so net present value always provide us the answer in digits, in dollars. So that is why it is called absolute approach. But on the other hand, IRR is going to provide us answer in percentage. So that's why it's called rate of return. So the IRR is the average rate of return based on cash flows offered by a project is called internal rate of return. So simply what it is, as I told you, so IRR is a relative approach. It is relative approach meant to say it is going to give you answer in percentage, and the IRR means say it is the average rate of return, and it is based on what? Cash flows, not on accounting profit. So it is average rate of return which we expect from the project, right? That the project should generate it. So that is what is called internal rate of return. So but here, as I told you so far, just assume it is a percentage. It is a percentage because now concept we are going to discuss. So here we go, how to calculate this percentage. Okay, so let me tell you here. So please guys, it's really important thing. Because last time when we calculated NPV, for example, I'm just assuming, uh, let's assume at, let's assume 10% cost of capital, at 10% cost of capital, what was happening? So for example, our NPV was positive. What? NPV was positive. Let's assume. I'm just saying, okay, this statement. And for example, at 15% cost of capital, let's assume our NPV is negative. So whenever our NPV is positive, positive NPV implies that our return is greater than cost of capital, which is 10% here. Okay, for example, for example. Okay, so as I told you, so whenever NPV is positive, so this statement you have to memorize. So whenever NPV is positive, so it is always mean that our return is greater than cost of capital, or simply the project's earning is more than cost of capital. For example, we calculated another NPV at 15% cost of capital. Let's assume. So at 15% cost of capital, our NPV was negative. Our NPV was negative. And negative NPV implies that our return is less than cost of capital. Okay, for example, 15%. So cost of capital, I'm assuming here 15%, right? Here I assume 10%. So let's assume at 10% NPV was positive. I'm saying now final statement. So it means our return is greater than cost of capital. It means our return is greater than 10%. But on the other hand, our NPV at 15% is negative. It means our return is less than cost of capital, which is 15%. It means our return is in between 10 and 15 because return is greater than 10%, but it is less than 15%. It means the internal rate of return is in between this. So we'll exactly find out that point. Okay, like how to find out that point, which is called interpolation. Interpolation means when you calculate NPV, IRR between positive NPV and negative NPV, because IRR will be in between. That is called what? Concept of interpolation. So that we'll find out. So this point, like what is IRR between 10 and 15%? So this we will find through the formula. Okay, the formula we will apply. So that formula will exactly tell you like this is the IRR amount, right? So this is the one concept of IRR, right? So now usually IRR we can also say this way. For example, let's assume I'm assuming IRR. Please try to understand. Okay, I'm assuming my IRR is 12.5%. Assume. First what I said, because these statements are important. Wallah. So on the concept, on the means a whole IRR concept is based on this thing. Okay. So first is what? NPV. Whenever NPV is positive, it means return is greater than cost of capital. For example, return is greater than 10%. And at 15% NPV was negative, it means our return is less than 15%. So then what is return? Return is in between 10 and 15, right? So that point is called IRR. So let's assume that point is 12.5%. As I told you, this point usually we will find through the formula. Okay, so let's assume this is 12.5%. Now, let me tell you, this is this is how IRR is also explained. Sometimes this is the definition of IRR as a return, as definition. For example, they're saying if project cash flows are discounted at IRR, okay, the NPV would be zero. What this means? So for example, I'm saying that, so whenever you calculate NPV, let's assume for NPV, we need first years, na? Let's assume year 0, 1, 2, 3. And then we write here net cash flows, right? For example, here we have 100 investment. I'm just assuming, right? And here I'm just assuming we have inflows of $50, $60, $30. I'm just assuming. And now, for example, if these cash flows you will multiply with the discount factor. Discount factor means a present value factor. But that present value factor you have to pick at IRR. For example, if IRR is 12.5%, okay, so we have to pick present values factor at 12.5%. So we have to pick, okay, from the table, or you can calculate by using that formula, right? So we have to pick the present value factor at IRR, whatever you will have present value factor. In year 0, we'll have 1, and here you have to calculate actually, okay, for 2 and 3. And then you will get here present values, right? So once you will get your present values by multiplying these values, so you will get present values of investment and present value of inflows. So exactly what will happen here, NPV will become 0. So this means what? Whenever project cash flows are discounted at IRR, so NPV should be 0. Okay, that is the actually point of IRR. Because what? Why it is 0? Because we assume that whatever, if you are keeping IRR as a discount factor, so we assume here, let's say whatever we will earn, so that we will pay to the investors. It means our earnings or our return equals to our cost of capital. So whenever this point will happen, obviously what will happen? NPV 0. Right or wrong? So sometimes IRR defined this way, that IRR is a discount rate at which NPV of the project will become 0. Okay, this is another way. And one more thing here, guys. For example, I'm just assuming, let's assume, please. So this is another point. Now I'm going to explain this point. Okay, what is this point? For example, I'm assuming now, let's assume our IRR is, let's assume 13%, I'm assuming. And our cost of capital is 10%. So whenever IRR is greater than cost of capital, it means our return is more than cost. So it means we have a profit. So it means we should accept the project. And this is the CN rule. Whenever IRR is greater than cost of capital means, say, if, for example, original cost of capital is 10%, original, I'm saying original, like that you are using in the NPV, that is 10%, original cost of capital, but IRR is 13%, for example. Whenever IRR is greater than cost of capital, so we'll accept the project. Okay, and whenever IRR is less than cost of capital, we will reject the project. So here, whenever IRR is greater than cost of capital, so how much is greater here in my example? 3%. It means return is greater than cost of capital by 3%. So this 3% is also called margin of safety. Okay, so it means the difference between actual rate means say this 10%, which is the original rate, discount factor, okay, used to discount the cash flow, and the IRR indicates the margin of safety. Please guys, don't mix this cost of capital here with this cost of capital in my example, because here this is the, for the sake of just provement that whenever you will keep discount factor equals to cost of capital, NPV will become 0. This is the definition of IRR. But this cost of capital means a original cost of capital, okay, where at first NPV will be calculated. So that I'll show you, don't worry now. Okay, so this is what is the points regarding IRR. Now here we have here some calculations. Please remember, as I told you, for IRR, it's really important now. So we need two NPVs. So this is what I'm going to explain now, how to, calculate the IRR. Calculation part I'm going to show you now. Calculation part. So how to calculate IRR? So first of all, guys, please, we always need two net present values. Two NPVs we need. Please make sure. We need two net present values. Two. And this step we will follow. Number one here, first point. We will calculate net present value using company's cost of capital. What it means? So here it means we will calculate original NPV. So we'll use original cash flows and multiply by original cost of capital. Okay, so you will get one NPV. So first NPV you will always calculate by using original data. Okay, original cash flows and original cost of capital. That is called first NPV. Now, if first NPV, if first if first NPV is positive, so then what we need? We need second NPV as negative. We need. Right or wrong? For example, if let's assume, I'm just telling you, for example, at 10% cost of capital, which was our original cost of capital, our NPV was positive. This is the first NPV, right? Now what you will do? You will calculate now second NPV negative. So here, so we will assume, I'm using word assume. Assume that is cost of capital. We will assume the cost of capital percentage. For example, let's assume 15%. Second rate will always be assumed rate. So whenever first NPV is positive, if first NPV is positive, so we need second negative NPV. And whenever you need second negative NPV, so we will increase the cost of capital. And we can assume that rate. For example, if first rate was 10%, second rate could be 15%. Right or wrong? And on other way around, if first NPV, for example, let's assume first, now another way around, okay? Let's assume if first NPV, this is first NPV. If first NPV is negative, let's assume at 10% it is negative. I'm assuming if first NPV is negative, it means then second NPV which we need, that must be positive. Okay, that should be positive. I should not use the word must. So that should be positive. Okay, so to get the positive NPV, what we will do, we will assume the second cost of capital, which we have to reduce it now. For example, that could be 5%. So it means, please remember, if second NPV you need negative, so you will always increase the cost of capital. If second NPV you need positive, right? Positive, then you will decrease the cost of capital. This is the rule here. Okay. So because NPV, because our IRR is between positive and negative, I told you at the start. That's why we need two NPV. One is positive and one is negative. This is what is written. So step number one is written what? We will calculate the normal NPV by using company cost of capital, original cost of capital. And step number two, having calculated the first NPV using company's cost of capital, calculate the second NPV we need now. Okay, by using second discount rate or second cost of capital. And second cost of capital you can assume. If the first NPV is positive, I told you first NPV is positive. Okay, use the second rate that is greater than the first rate. As I told you, whenever first NPV is positive and you need second NPV negative, you will always increase the cost of capital, and that rate you can assume, any rate you can assume, but it should be bigger than first one. Okay, but if first NPV is negative, so then you need second positive NPV. So for that, you will decrease the discount rate. Okay. So, and then what we will do, then we will apply this IRR formula to calculate the internal rate of return. Okay. And what is the formula? This formula is that I'll explain with the help of example. So here first I'm explaining what is the formula. So IRR, which is internal rate of return. So you will calculate this way. So L stand for here lower discounted, because there are two cost of capital, for example, 10% and 15%. I'm assuming at 10% NPV is, let's assume, I'm just assuming. So NPV is 1000 positive, just assume. And at 15%, for example, NPV is, let's assume 600 negative. I'm just assuming, okay? So this is the status. Here we have a positive NPV. Here we have a negative NPV. Just assuming, okay? So what we will do, how we will calculate IRR? First, we have to take it here. L. L stand for what? L stand for lower discounted, which is lower between these two, 10 or 15, 10. So I'll write it here 0.10 because 10%, right? So if I remove the percent, it will become 0.10. 0.10. Okay, 0.10 plus now bracket. NPV at L. NPV L means say net present value at lower discount rate. Like what is NPV at lower discount rate? So NPV at lower discount rate is 1000. This is numerator. Divided by NPV at L. NPV at L again, NPV at lower discount rate, which is 1000. Then this is minus sign here, right? This minus in the formula. And second NPV is negative, that is also minus. So this minus and this minus, okay, will become what? Plus. Original sign is minus here, okay? Here minus. But now it will become plus. Why? Because this minus and the minus of second NPV will become plus. Plus NPV at higher cost of capital. NPV at H means NPV at high discount rate. So high discount rate is what? 15 and NPV is 600. Bracket close. And then we have here higher discount rate minus lower discount rate. Higher discount rate minus discount rate. Higher discount rate is 0.15, 15%, minus 0.10, which is 10%. So if you will solve it, so you will get internal rate of return. And you know how to solve it. Please, first you will solve this area, like 1000 divided by this denominator, then multiply with this difference, and then plus whatever you will get answer, then plus with this 0.10. And if you want answer in percentage, obviously add then the whole answer, you can multiply with the 100 to get the answer in percentage. Okay, this is what is the IRR formula. Now let's have a look. Please, here one more thing, let me tell you here. Decision rule I have already told you. For IRR, whenever project IRR is greater than cost of capital, so we can accept the project. If IRR is less than cost of capital, we can reject the project. Here, IRR, what we have calculated by using the formula, and the cost of capital means the original cost of capital. Okay, not the assumed one, original cost of capital. Okay, the first one. Okay, so here we go. We have here example now. As I told you, IRR, to calculate IRR, we need two net present values, positive and negative. So here we have a small question, for example, just to see, okay, how to calculate NPV or IRR. So here we go, guys. So we have a one question here. For example, the question is, let's assume that they are telling you the company discounts the relevant net cash flows using hurdle rate. Hurdle rate means the cost of capital is 6%, which is desired rate of return. It's also got desired rate of return, cost of capital, weighted average cost of capital. Okay. And what is the data? This data is given. For example, he told you period. This will be given in the question, like project life. For example, we have initial investment and project life is till 8 years. We'll write year 0, this is 0, then 1, 2, 3, 4, 5, 6, 7, 8. And here we have a net cash flows. I told you in NPV how to find out net cash flows. Okay. So for example, it is given here. Let's say we have a 500, 100 and 1000 as a investment. Then we have this series of inflows in every year. We'll write it. And this discount rate is given. Simply once we got net cash flows, we'll multiply by discount factor at 6%. And I told you, you will go to present value of $1 table. From there at 6%, you can find these factors. In year 0, it is always 1. From then year 1, 2, 3, 4, 5, 6, 7, 8. So you can find this from the table. Then you will multiply. So actually, this is the original cost of capital, 6%. Now what we will do, once we will multiply cash flows with the present value factor, obviously. Once you will multiply, so you will get these values, right? These values you will get. Now what you will do? So I'm assuming you have idea about NPV, okay? So that is why, because after NPV, we are studying IRR. So now what, guys, we are doing here. This is the present value of outflow is given. And these all are present values of inflows. So if you will net off, so this is called NPV. So this is NPV now. Net present value. So here net present value is positive. It means what it means now? Tell me. It means wherever NPV is positive. Now please understand. NPV is positive here, right? It means our return is greater than cost of capital. Cost of capital is what? 6% here, right? It means our return is more than 6%. That is why NPV is positive, right? Now what we'll do, we'll use same period, same cash flows, just we'll change this information. We'll assume second rate, assumed rate, because first NPV is positive. We need second negative NPV. So we'll increase the rate, okay? So and we'll change the rate. That is assumed rate. We can assume it and we can calculate another NPV. So let's have a look. So now same thing. We will write period as it is given the first example. So we'll write net cash flows, it's also given. Just we increase the rate from 6 to 7% here. In your exam, you can increase more rate, maybe by 5%, 6%. It's fine. Okay, so we increase to 7%. So then at 7%, we took present value factor from present value of $1 table. Okay. And then we'll multiply with the cash flows. So you'll get these are the present values. So this is the present value of outflows. This is the present value of inflows. If you will net off this, call your NPV now again. So now here NPV is negative. It means what happened now? Please remember here. Now try to understand. At 6%, what was happening? NPV was positive. So positive NPV means our return is greater than 6%, which is cost of capital. But at 7%, our NPV is negative. It means our return is less than 7%, which is cost of capital. It means our return is between 6 and 7. Right or wrong? So now we will apply the IRR formula to find out the exact point, like where we have what is the IRR? Because IRR will be between 6 and 7%. So how you will find it? So let's have a look. So I'm just writing here. Negative NPV is how much? 10,758, and positive NPV was 9,653. 9,653 and 10,758. So now you'll apply the formula, guys. So what is the formula? IRR formula. So you can just cross check on your calculator. So IRR, how you will calculate? IRR equals lower cost of capital first. Lower cost of capital plus NPV at lower cost of capital divided by NPV at lower cost of capital minus NPV at higher cost of capital multiply by higher cost of capital minus lower cost of capital. So we'll apply the formula. For example, lower cost of capital is 6% here, right? So 0.06, right? Without percentage, I'm removing percentage plus. NPV at lower. NPV at lower is how much? 9653 divided by NPV at lower 9653. And now here we have a minus formula. And second NPV is also negative. Negative because second NPV was negative. So this minus from the formula and minus of negative NPV will become positive. So it will become 10,758. And then multiply by higher cost of capital is how much now? 7%. 0.07 minus lower cost of capital is 6%. 0.06. Now if you will solve it, you will get IRR. Okay. How you will solve it, please? First, you will solve this area I'm highlighting on your calculator. Take this 9653 divided by, add these two values and divide. And then whatever answer you will get here, this answer will be multiplied with this difference. This difference 0.07 minus 0.06. So with this difference you will multiply. So whatever answer you will get, so if I'm not sure, let's try it. It will take time, by the way. So we have here 9653 plus 10,758. So if I'll add these two values first, these two values, so the total is 20,411. So now I'll divide. So what we got here? Okay. Now we'll take 9653 divided by this 9653 divided by this total 20,411. So you will get here it as 0.4729 rounded value. I'm just writing, and plus 0.06. And now here we have here, solve this. It will become 0.07 minus 0.06. It is 0.01. So now you will multiply these two values. 0.01 multiply by 0.4729. So you will get it here 0.004729 plus 0.06. Now you will just plus this value plus 0.06. So you got, if you solve this, you got a 0.064729. Because I want to get answer in percentage, I can multiply with 100 now. So, so 0.06479 multiplied by 100. So you got it here how much? 6.47 or 6.5% your IRR. So see, because at 10%, 6.5 is IRR. As I told you, at 6% NPV was positive, at 7% NPV was negative. It means IRR is in between, so that is 6.5%. Understood? This is how you will calculate IRR. And now tell me, project should be accepted or not? Yes. So if IRR is greater than original cost of capital, IRR is 6.5%. Original cost of capital was 6%. Original cost of capital is the capital which you are using in the first NPV. Whenever IRR is greater than cost of capital, it means you have profit. So project must be accepted. Okay, guys, is that clear? I hope so it is clear. Okay. Now, guys, coming back now here, this is what IRR calculation. Now we have more important thing, which is more about evaluations, because difficult questions with long cash flows, I cannot do it right now because first we are covering concept, whole concept we will cover, technical points, theoretical points, and then we'll go through the questions. So here we go. We have here merits and demerits now, advantages and disadvantages we are telling you. Okay. Okay, guys, one more thing. Can I ask you, for example, you will tell me now, huh? Just use your mind, okay? So for example, let's assume this is another thing I'm just telling you. For example, at 6%, I'm just assuming it's another data. Our NPV is, let's assume, positive, for example. NPV is positive. Then what? Let's assume positive is what? It is 1000 positive. Then we calculated second NPV negative. So I tried, let's assume 10% rate. And what happened? At 10% NPV still is positive by, let's assume, $20. See, both NPV is positive. Can I calculate IRR? Yes, I can calculate. It's not necessary both NPV should be, one should be negative and one should be positive. No. So you have to follow the concept. Let's assume if it is at 10, at 6%. If your NPV is positive, it means return is greater than 6%. Okay, great. And then you tried 10% and NPV gain positive, it means return is greater than 10% also. It means return is more than 10. So if both NPVs are positive, still you can IRR, you can calculate IRR. How it you can calculate? Let's assume. So what was the formula? Look at here. IRR formula was, please, it's just a math now. So IRR formula is lower cost of capital into NPV at lower divided by NPV at lower minus NPV at higher cost of capital into higher cost of capital minus lower cost of capital. Now see what is the formula. So here you will write 6%, 0.06 plus. NPV at lower is how much? For example, 1000 divided by 1000. Now this is the minus in the formula. Second NPV is positive. So positive and minus will remain minus. Right or wrong? So now you will write NPV at higher cost of capital, higher, that is what, 20. Okay, see, just sign is changing here, right? Multiply by higher cost of capital, which is 10%, lower cost of capital, which is 6%. Trust me, if both NPVs are negative, still it can be calculated. Okay, so this just you have to remember. So please remember here, two words I'm going to add here. Whenever we use negative NPV and positive NPV to find out IRR, this concept is called interpolation. Interpolation. So when both NPV is positive, for example, first NPV is positive, second NPV is positive, and we are calculating IRR, that is called extrapolation. Or if both NPV is negative, for example, first NPV is negative, second NPV is also negative, and we are applying the same formula, just mathematically sign will change only. So again, we calculate the IRR, that is also called extrapolation. So whenever you are calculating IRR by using positive and negative, it is interpolation. Both positive or both negative, that is called extrapolation concept. Okay, so because just you have to amend the formula. Now, we have here some comparisons, please. It's really important. So first I will discuss generally merits, overall merits of IRR, and then we'll compare with NPV, what we discussed in NPV, because sometimes questions they are in comparisons. Okay. So first, just simply we are discussing what are the merits of IRR. Number one, it consider the time value of money. Yes, because we are using discounting concept here. So it consider the time value of money, which was not considered in payback period, in simple payback period and in accounting rate of return. But IRR considers the time value of money. This is the first advantage. Second advantage is what? It is based on cash flows. Yes. It is not based on accounting profit, which are subject to window dressing. So it is based on cash flows, which are more factual as compared to accounting profit. Number three, it considers the whole life of the project. Why it is advantage? Because payback period doesn't consider the whole life of project, but IRR considers. In that context, it is an advantage. Then it is a percentage term. Yes, IRR will give you answer in percentage, which is easy to communicate and understand even by non-financial managers, right? If you will tell someone that, sir, if you invest even $1, so you will get, let's assume, 2% return on that, right? So it is easy to communicate, right? Then what? A company selecting projects where IRR exceeds the cost of capital should increase shareholder wealth. Yes, if IRR is greater than cost of capital and you are accepting the project, it means this project is going to add value to the shareholders' wealth. And please remember, it calculates the break-even cost of capital and margin of safety. Yes, I told you if you will discount project net cash flows at IRR. Means the IRR you are using as cost of capital. So what will happen? NPV will be zero. Yes. So it means this is the break-even point. Break-even point means if you are want the day when your actual cost of capital will be equal to the IRR, obviously you will not get anything. So this is what it means. Like it can calculate the break-even point. So it means you have to be very careful. So your cost of capital should never be equal to the IRR. In reality, if it will be equal to the IRR, obviously you will be at break-even point. No profit, no loss, NPV zero. Margin of safety is what? For example, if IRR is greater than cost of capital, that is margin of safety also. If IRR is greater, then what are the disadvantage? We have some drawbacks. Number one, it gives conflicting result with NPV. Yes, this point we will open just after a few minutes. Sometime it is having conflicting results. Okay, so please remember, I'm giving you for the sake of examples. For example, we have a two project A and B. I'm just saying it because I'll explain in more detail later. So we have, let's say we calculated IRR. Here IRR is 10%, here IRR is 12%. It means based on IRR, project B is better. But when you calculated NPV, for example, here NPV is $2,000 positive, here is 500 positive. It means based on NPV is project A is better, not B. So whenever there is a conflict, for example, if there is a conflict, preference will always be given to NPV, not to the IRR, because NPV tell you exact amount, like with which amount your wealth, a shareholder wealth will increase. Okay, so then there might be a problem of multiple IRR. Yes, this I'll also open now. Okay, now we have some other points, assumptions. Okay, assumptions of IRR that we'll assume that cash flows are reinvested at IRR, that I'll explain now. So these disadvantages are really important. So let's have a look point by point. First, remember here. Okay, so point I'm going to explain now. So these, because all discussions now about okay. Now please hear. Because there was somewhere in the written as a disadvantage here that there are the point of multiple IRR in case of non-conventional cash flows, multiple IRR. So this point we are going to open now. So here we go. Okay. So first let's understand the point we are going to discuss here, this node we are going to study. So whenever there is a conflict between results given by IRR and NPV, then the decision given by net present value prevails. As I told you previously, right? That IRR says, just to give you example, IRR says project B is better, NPV says project A is better. So which method will be preferred always? NPV. Because it is superior method, because it will give you answer in exact absolute dollar. Like what, with which value or how much value you will get with the NPV. Okay. So here now we are going to discuss, this is really important. So we always say if there are non-conventional cash flows, so there is a problem of multiple IRR, or IRR can mislead you. Okay. If there is a non-conventional cash flows. So first understand the word, what does mean by conventional cash flows and non-conventional cash flows. So here we go. Guys, this is first time explaining what is the conventional cash flows. Conventional cash flows is like that. For example, a project, this is the project life year 0, 1, 2, 3, and so on. So conventional cash flows means that you have one investment and then you have a series of inflow. Okay, like initially you have an investment, and later you have inflows. So that is called conventional cash flows. And then what is the non-conventional cash flows? Non-conventional cash flows means, for example, maybe this is non-conventional now. Like for example, here maybe I have an investment 100. Here I have a $30 positive cash flows. Here again I have a $50 of investment. Again I have a, for example, 150 cash flows, like that. So here cash flows are changing sign. So this is called non-conventional cash flows. This is also non-conventional. For example, if first I'm receiving inflow and then I'm investing, let's assume I'm showing as an outflow 150. So this is also non-conventional. Okay. So please remember what's the difference. Conventional cash flow means when you have a initial investment, then you have a initial investment is followed by a series of cash inflows. But non-conventional cash flows means say cash flows are changing signs over the project, like something positive, something negative. So this is called non-conventional. In non-conventional cash flows, so IRR can mislead you. Totally, it can mislead you. So here we go. Let's have a look with the help of example. And before moving to the example, I need to go through other points also. Okay. Now here, this is what is they are saying that I have explained what is the conventional and non-conventional cash flows. Okay. This is the 3 points regarding that. So I have told conventional and non-conventional. Now here we go. I already first I'm going to deal it here with. Please remember here. I'm going to go through these points, and with these points will I like tag the examples now. So here we go. First point. IRR method is more easily understood. This I already told you the advantage, because it is percentage term which can be easily understandable by even non-finance background people. But if you will show someone NPV calculation with to those people who don't have a finance background, they will not understand anything. Second, NPV technique is technically superior. I told you whenever there is a conflict between NPV and IRR, preference will be given to net present value. Now here we go. This is important point. Okay. When cash flows pattern are conventional. Conventional, I told you, right? Like you have a one investment and that investment is followed by series of cash inflows. So if cash flows pattern are conventional and projects are non-mutually exclusive. This is another word. So two words are important here. Cash flows are conventional and projects are non-mutually exclusive. Or projects are not mutually exclusive. What is mutually exclusive? Understand the word. Mutually exclusive mean to say, for example, you are a student. So you got a two option. You can do CA, or you can do, for example, two option. You can do CMA and you can do CPA. So now let's assume these are two competing degrees. I'm assuming only, okay? These are two competing degrees. So you are one person. So you have to choose one out of these two. So obviously you will choose the best one, whatever the best is. So you will choose that one, right? So if that is called mutually exclusive means you have two competing projects in terms of investments. So mutually exclusive means you have a two competing projects, but one you have to choose. Only one you have to choose. That is called mutually. And non-mutually means say these projects are not competing. So maybe all you can choose. That is non-mutual. Okay. So here, please remember here, this is an important statement I'm saying again. So if cash flows pattern are conventional and projects are non-mutually means say projects are not competing projects. So in that scenario, what will happen? So both method means say IRR and NPV will produce the same result. So what it means? It means this is what it means. For example, the project A, project B, both are different projects, non-mutually projects. We calculated IRR. IRR is 15%, here it is 10%. Based on IRR, this project is better. We calculated NPV. NPV here is 2000, here is 500. So based on NPV, again, this project is better. So it means here if projects are, if cash flows are conventional and projects are non-mutually, so both method will give you same decision. See, IRR also says accept the project A, NPV also says accept the project A. So this is what it means. So please, this point is important. Don't take it light, this word. So remember these words. If cash flows are conventional and projects are non-mutually, so both method will give you same result. So when both method will give you different result, then this is what is the question, right? So here we go. So if, please remember here. Okay, please remember here, NPV. Now this point I'm telling you here. The NPV method and IRR method may produce different results. If projects are mutually and cash flows are non-conventional. See, here if cash flows are conventional and projects are non-mutually. So both methods will give you same decision, but both method can give you different decision if projects are non-conventional and projects are mutually. Okay, so in that scenario, if cash flows are non-conventional and projects are mutually exclusive, in that scenario, so both method can give you, you know, different decision, and even IRR can mislead you here. Okay, in that scenario, please, whenever you have a non-conventional cash flows and you have projects and mutually exclusive, for preference will be given to NPV because both method can give you different picture. So preference will be given to NPV. So I'm going to show you with help of examples. Here we go. Let's assume we have here, please, here we go. We have two projects here. Understand, try to understand. I'm trying to explain with help of example. Because whenever projects cash flows are non-conventional, as I told you, IRR can mislead you. I'm telling you. It can mislead you simply. Okay, but in that scenario, you have to give preference, you have to give to what? To the net present value. And if cash flows are non-conventional, again, IRR and NPV can produce different results. And again, preference will be given to NPV. And in non-conventional cash flows, another point, there could be a problem of multiple IRR, then more than one IRR can be calculated. So it is almost same thing I'm saying from different angle. So what I said, first I said if cash flows are non-conventional, IRR can mislead you. If cash flows are non-conventional, there's a problem of multiple IRR. If cash flows are non-conventional, IRR and NPV can give different results. So preference will be given to NPV. This is what I said. Now, so here, please remember, below are the net cash flows of two potential capital projects. Let's assume we have two projects. Assume. So we have a project X and project Y. Please see the difference. What's the difference? Okay. Project X requires initial investment. Then it is inflows. It is conventional cash flows, right? Because first we have initial investment, then we have a series of cash inflows. But project Y is having first inflow and then investment. Maybe it's a advance receipt first, then investment. So it means here we have a non-conventional cash flows, right? So it means project X is having a conventional cash flows and project Y is having a non-conventional cash flows. Okay, so what will happen now? Look at it. See. And so here we go, guys. So we have a non-conventional cash flows. So what we are going to do here, please remember here, for example, if I will calculate the IRR for both projects, I'm assuming IRR is 8%. For example, for both projects, we have calculated IRR. Okay, for IRR, you need two NPVs, positive, negative, you know it, right? So let's assume we found the IRR as 8%. Let's assume 8%. So how now I'm going to prove that IRR is 8% for this project. Actually, it is 8%. Why? For example, because at 8%, both project NPV for project X and for project Y, both projects NPV will become 0. This is what is the IRR definition, right? So if you will use IRR as a cost of capital, NPV will become 0. So let's try it. By the way, IRR is 8%. Okay, this is what is written here. So IRR for both projects is 8%. So we can prove this way. For example, calculate the NPV. Project X, we have here, for example, first investment, then inflows. This is year 0, this is year 1. Okay, and at 8%, if I will use the cost of discount rate. So here we have a 1, here we have a 0.926. So this value you can find, go to present value $1 table, find out at 8%, right? So you will find this value there. And if you will calculate here, look, if you will multiply these two values, you got these present values. And if you will net of these, so you got NPV 0. Here it means NPV 0, it means IRR is really 8%. Same here for project Y we did. We took the Y cash flows. So this is first for Y, it was first inflows, then outflows. And at 8%, we pick the cost of capital. In year 0, it is always 1. In year 1, this is the value. So once you will multiply, you got these present value and again NPV 0. It means here NPV is also 0 at 8%. It means for both project IRR is 8%. Understood? Okay, so far it is clear. So look at here, please. Now I'm just adding some extra information with this example. Now, please see what I'm saying now, what I'm doing now, because now it is the point. For example, I'm assuming my original cost of capital, what? Original cost of capital is 6%. And my IRR is 8%. Assume. Original cost of capital is 6%. And my IRR is 8%. It means based on IRR. So these both projects should be accepted because project X is having 8% IRR. Project Y is having 8% IRR. This is IRR. And I'm assuming cost of capital is what? 6% for both projects, for example. Now see how IRR is misleading, please. So cost of capital is 6%. So it means here, whenever IRR is greater than cost of capital, so what we say, we always say, yes, we should accept the project. We should accept the project. It means based on IRR decision, project X should be accepted. Project Y should be accepted because IRR is greater than cost of capital, right? Am I right or wrong? And I proved that IRR is 8% because NPV is becoming zero there. And let's say if original cost of capital is 6%. So I'm saying that, so at IRR is greater than cost of capital, both projects should be accepted, X and Y. But look at here. But if you will literally calculate the original NPV at 6%, only NPV, see the picture will change in non-conventional cash flows. What will happen? So this was the conventional cash flows, right? Project X conventional. First investment, then inflow. And I'm assuming my original cost of capital is 6%, for example. At 6%, let's assume if I'll pick the present value factors and I'll calculate the present value here, NPV is positive. So see, in conventional cash flows, this is conventional cash flows, NPV is positive. But if it is non-conventional, what happened? Same, I'm using same cost of capital. So non-conventional cash flows, what? For example, in year 0, this, year 1, this. And we have here at 6%, these are the factors. But these are non-conventional cash flows. Okay, and just we calculate the present value. So now the NPV became what? And we became negative here, 4080 negative. See, here 4080 positive and here 4080 negative. Now look at here what happened. Try to understand here. If you will look just decision based on IRR. IRR was saying that, oh, X is acceptable, Y is also acceptable because IRR is greater than cost of capital. But when you calculated NPV of the project, NPV of the project for X, NPV is 4080 positive. For Y, it is 4080 negative at 6%. Okay, now see, NPV says that don't accept Y, accept A, right or wrong? So it means, but Y, but IRR saying that accept Y also. So it means now see, these are the conflicting results. So IRR will mislead you, I'm telling you always, if cash flows are non-conventional. So it may mislead you. Okay, so that is why what you have to do whenever cash flows are non-conventional. Okay, so the preference will be given to NPV. So this is one example of that. Based on NPV, you will decide which project you have to accept. So you have to accept positive NPV project, not negative NPV. Understood? This is the problem. So this is how, in case of non-conventional cash flow, IRR can mislead you. Then we have here another example. For example, now here we have a non-conventional cash flows and we have a mutually exclusive project. Again, same story I told you. Whenever projects are mutually exclusive means you have to select one. If even you have three projects mutually exclusive, it means these three are competing projects. So you have to choose one. So whenever projects is mutually exclusive, right? And cash flows are also non-conventional. So again, if IRR and NPV is producing different results, so preference will be given to NPV. So here we have a small example just to understand. Let's say we have a two project S and T. And here we calculated, this is like a conventional cash flows. And here we have a non-conventional cash flows again. Here we have IRR 12% and 10%. Just example, they are saying that, okay? If capital is available for only one project, because mutual exclusive means one you have to pick. So using IRR alone, what we have to pick? We have to pick project S. Why S? Because project S IRR is bigger. But when we calculated NPV, for example, we calculated NPV, let's assume for both projects, by using original cost of capital. So for project NPV is 10,000, for example. I'm using cost of capital again 6% here. See, we calculated IRR first. IRR says project S IRR is 12%. This is IRR. And T is 10%. So based on IRR, S is better. But original cost of capital is 6%. When I calculated by using same cash flows, I calculated, I will write cash flows or project S. And at 6%, I'll pick the cost of capital and then 6% again. So my NPV is this. Again, cash flows for project Y, I'll pick. And multiply with the cost of capital at 6%, my NPV is again positive. But where NPV is bigger? Here is more bigger, 11,000 something. Here we have 10,000 something. So, but projects are mutually exclusive. So we have to select one. So which one we will accept? T. So IRR says that S is better, but NPV says T is better. So preference will be given to NPV always. Okay. So this is what is the point. So whenever there is a confusion, confliction between NPV and IRR, preference will be given to net present value, not IRR. Okay, guys. And then what are the some other points are there? Please don't take these points light. Okay. And here one more thing I want to tell you. Let me explain first these points. So we have another drawbacks. It was written in demerits also of about reinvestment rate. Please, this is also NPV IRR comparison. I'm telling you. Please remember, in NPV, see for example, we have these are the years, year 0, 1, 2, 3, and these are we have a net cash flows after tax. We have 100. Then we have a 15 flows, 16 flows, 17 flows. So what we assume, this cash flows, surplus cash flow, which we will get at the end of first year, this will be reinvested for remaining 2 years. These cash flows, which I will get at the end of 2 years, this will be reinvested for remaining 1 year. And this you don't need to reinvest because you are at the already end of the year. So what is the reinvestment assumption? So in NPV, we assume these cash flows will be in NPV. We assume these cash flows will be reinvested for remaining period at cost of capital, which is practical, original cost of capital. But in IRR, we assume that these cash flows, surplus cash flows, will be reinvested at IRR also. For example, if cost of capital is 6%, okay, so NPV is more practical, so these cash flows can be reinvested at 6% in other options, no problem, for remaining periods. But if IRR is 20%, so maybe IRR assume that you cannot achieve IRR until unless you will reinvest at 20%. So it is very high now. Maybe I will not find uh, the investment option which can generate 20% return for me for remaining 2 years or 1 years, right? So that is impractical. So point is, we assume in NPV the reinvestment rate is cost of capital. In IRR, reinvestment rate is IRR itself, and which is impractical in case if IRR is high. Okay, so that's it. So reinvestment we discussed here. So this point I already told you, you can go through this point now. Next point, IRR method assumes that cash flows will be reinvested at internal rate of return, I told you. Because NPV assume that cash flows are reinvested at cost of capital. These are 2 points. Great. What is the next point? If one or more mutually exclusive projects is there. So if 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 one of two or more mutually exclusive project is accepted, the other must be rejected. As I told you, project X and Y, two are mutually. If you're accepting X, so Y must be then rejected. Or if you are accepting Y, then X must be rejected. Okay, that's what it means mutually exclusive. It's a competing projects. Then please remember here, we have other points. NPV and IRR method may rank mutually exclusive project differently. I told you that if projects cash flows are non-conventional, projects are mutually, so IRR and NPV may give you different decision. Okay. And the point is that why now here, the point why NPV and IRR is giving different decision. Previously, I told you if projects are mutually exclusive and projects cash flows are non-conventional, NPV and IRR may give you conflicting result and NPV will be preferred. But the point is that I told you, the point is why they are giving conflicting result. This is the answer to why. There are different reasons. Number one, maybe the cost of one project is different than the cost of other project. Maybe for one project, cost of capital is different. For other project, cost of capital is different. So that is why maybe they are giving different results. Then the timing, amount, and direction of cash flows differ among the project. As I told you, maybe one project is having conventional cash flows, another project may have non-conventional cash flows. That is where they may give you different decisions. Okay, then, or the third reason could be maybe the project have different useful life. Maybe one project is for 5 years, second project is for 6 years. Again, maybe NPV and IRR may give you conflicting results. So the point is, okay, the point is whenever there is a conflicting result, so preference will be given to what? NPV, not to the IRR. Understood? And this after this point, now let me tell you, this point is also important. I'm not sure this is clear on, you can read it or not proper on screen. So, but there is a shortcut way, to calculate IRR. But this shortcut way you can apply only if cash flows are constant. Constant, for example, let's say these are year 0, 1, 2, 3. Here we have a investment of 100. Here we have a cash flow 50, 50, 50. So these are called constant cash flows. In that scenario, you can use first way, as I told you, find out positive NPV, then negative NPV, and find out interpolation IRR formula and find out the IRR point. But if there is a conventional cash flows, okay, we have shortcut also. But if cash flows are non-conventional, I mean say not constant, not conventional, I should use the word. If cash flows are not constant, for example, let's say here we have 50, here we have a 60, here we have a 70. So obviously you have to follow the formula, find positive NPV, negative NPV, then apply the uh, IRR formula. Cash flows are constant. Let's assume 50, 50, 50. Again, you can follow the first way, which I told you. Find positive NPV, then negative NPV, and then apply the IRR formula to find out IRR. But we have shortcut way for this scenario also. Okay, shortcut way is what? What is shortcut way? Very simple. How to find the IRR? It's very simple. So what we will do here, first of all, we'll calculate the payback period. And what's the formula for payback period here? If cash flows are constant, we'll write initial investment divided by after tax annual cash flows. For example, let's read the question. This is the example, for example, here. A car company has a hurdle rate of 12% for all capital projects. This is cost of capital. Okay? Cork is considering project with initial cash outlay 200,000. This is initial investment 200,000. That will save 52,000 after tax cash cost in each of the next 5 years. Even they're saying in next 5 years, every year you will get 52,000 after tax. So this is what is called after tax annual cash flow, which is 52,000. 200,000, which is initial investment divided by after tax annual cash flow. So you will get payback period of 3.486 years. It means this project will take 3.486 years to recover its cost. That's fine. But now this figure, I will search in the annuity table, like where it is. I'll go to the present value of ordinary annuity table. This table is given in the question. And I will search first what is the project life, 5 years. Great. So I'll go to 5 years row, years 5 row. And then I'll find this answer payback is written under which percentage. These are the percentages here, right? So I'll find out this value 3.4846. 3.846 I'll find. 3 point in the year of row, in the row 5, okay, year 5, I have to find that value. So that is 3.486. 3.486. So 3.486, where it is? 3.89 is given, 3.79 is given. But we need 3 point. We need 3 point maybe 487, right? So sorry guys. So we need, here we have the values in between, maybe 3.846, 3.846. So 84 is greater than this, but 84 is less than this. It means your IRR is between 9 to 10%. Is between 9 to 10%. So it means you have to look in the question now what options are available. Any option which is available between 9 to 10%. So that will be your IRR. So this is the shortcut way. What is shortcut way? First calculate payback period. Then that payback period, depending on the life of the project, go to the annuity table, look in the life of the project and find out that values where it is written. So that is going to be your payback. Oh, sorry, IRR. I hope so it is clear, guys. Is it clear? So this is what we have discussed, the concept of IRR. Next class, I'll try to bring the questions, practice questions. Okay, of NPV and IRR, both we'll see and we'll cover the remaining part. This chapter is really important, guys. Okay, thank you so much. If you have any question, you can ask.